Well, I mean, the exciting thing to do would be some sort of electric vertical takeoff and landing supersonic jet of some kind.
Vertical takeoff and landing, meaning no need for a runway. Just shoot up straight in the air and then...
Elon Musk is at it again, shaking up another industry. This time, it's aviation. His latest reveal, the X-1 aircraft, isn't just a fancy jet. It's a $13 billion game changer. This isn't your average billionaire flexing his wallet on a shiny new toy. Musk and SpaceX have designed something that will rewrite the rules of air travel as we know it. After years of quiet development behind closed doors, SpaceX finally unveiled the X-1, proving that innovation doesn't always need a press conference. Sometimes it just speaks for itself. There's a lot to unpack here. How did it all start? And what is it? The idea for the X-1 didn't just pop out of nowhere. Musk and his team took inspiration from the US military's first next-gen airfighter prototype. But this one's unlike anything we've ever seen before. The X-1 aircraft redefines the meaning of speed, reaching a jaw-dropping 4,600 miles per hour. To put this into perspective, that's double the speed of the SR-71 Blackbird, a plane that held the title of the fastest aircraft for decades. The Blackbird was considered untouchable in its time, but the X-1 doesn't just beat it, it obliterates its record. The power behind this incredible feat is a compact space shuttle engine, specifically adapted from SpaceX's Hypersonic missile program. Unlike conventional jet engines, which rely on compressing and igniting air, this engine operates at a whole different level. It's optimized to handle the extreme conditions of hypersonic flight, including the intense heat and stress generated at such speeds. At 4,600 miles per hour, the X-1 can shrink the world in a way we've only dreamed of. A flight from New York to London, which usually takes around 7 hours, could be completed in under an hour. This level of speed doesn't just revolutionize air travel, it transforms global logistics. Military operations could respond to threats anywhere in the world almost instantly, while humanitarian aid could be deployed in record time to remote disaster zones. The possibilities extend beyond convenience into strategic and life-saving applications. But hypersonic speeds don't come easy. At this velocity, the aircraft encounters immense pressure and heat that would rip most planes apart. The X-1's advanced materials and design ensure it remains stable, even under these extreme conditions. It's a testament to SpaceX's expertise in aerospace engineering, showcasing just how far technology has come. That's just the start here. There's a lot more that makes this one of the best jets in history. Advanced camouflage technology speed isn't the X-1's only strength. It's also designed to be nearly invisible. Its advanced camouflage technology goes far beyond simple radar evasion. This is a plane that visually disappears into its surroundings, blending seamlessly with the sky. The camouflage system uses a combination of reflective materials and adaptive patterns that mimic the changing colors and lighting of the atmosphere. This isn't just theoretical. During a test flight, the X-1 demonstrated its stealth capabilities by causing confusion at the Pentagon. Radar systems detected an anomaly but couldn't confirm what it was, or even if it was an aircraft at all. Such an incident highlights just how far ahead the X-1 is when it comes to stealth technology. For military and intelligence purposes, this level of invisibility is priceless. A plane that can approach undetected has a significant advantage in reconnaissance and combat scenarios. It can gather critical intelligence, deliver payloads, or evade threats without alerting adversaries. This technology can also be used beyond defense. For instance, in disaster relief operations, the ability to approach areas discreetly could be invaluable in politically sensitive or hostile regions. By remaining unseen, the X-1 could perform crucial missions without escalating tensions or risking its crew. Extreme altitude capability. If the X-1's speed and stealth are impressive, its altitude capabilities are nothing short of extraordinary. Most commercial planes fly at altitudes between 31,000 and 38,000 feet, and even the most advanced fighter jets rarely exceed 50,000 feet. The X-1, however, operates at an astonishing 105,000 feet. That's almost triple the cruising altitude of a typical passenger jet and well into the stratosphere. At such heights, the air is incredibly thin and temperatures plummet to extreme levels. Traditional aircraft engines can't function in these conditions, but the X-1's space shuttle-derived engine thrives. It's specifically engineered to perform in near-space environments, where drag is minimal and efficiency is maximized. Flying at 105,000 feet isn't just about breaking records. It offers tactical advantages that are hard to overstate. At this altitude, the X-1 is virtually untouchable by conventional air defenses. Most surface-to-air missiles and radar systems are designed for targets operating at much lower altitudes. By staying above these threats, the X-1 ensures a level of safety and effectiveness that few aircraft can match. Not just that, but this high-altitude capability allows the X-1 to cover greater distances with less fuel, thanks to reduced air resistance. It also enables smoother flights, as it avoids turbulence and weather systems entirely. For military applications, this means missions can be executed with precision and reliability, regardless of conditions closer to the ground. Its hypersonic speed sets new benchmarks for how fast we can travel and respond to global challenges. Its advanced camouflage makes it a ghost in the sky, capable of operating undetected in even the most hostile environments. And its extreme altitude capabilities put it in a league of its own, flying higher and farther than anything else in the sky. Together, these features create an aircraft that isn't just ahead of its time, it's shaping the future. The X-1 isn't just about pushing limits, it's about rewriting them. Whether for military dominance, rapid response, or pioneering new frontiers in aviation, this aircraft is set to change how we think about the skies. These aren't the only great features here, though. It's great from the inside and out. Fuel efficiency. Fuel efficiency in the X-1 represents a leap forward, not just in aviation, but in how we think about balancing performance with sustainability. Its 30% improvement over traditional military aircraft isn't just a marginal gain, it's a shift in operational capability. This improvement allows the X-1 to conduct missions that were previously impractical due to fuel limitations. For military operations, longer range without refueling means fewer vulnerabilities. Refueling aircraft in flight is a risky operation that requires precise coordination and often involves vulnerable, slow-moving tanker aircraft. By reducing the need for mid-air refueling, the X-1 minimizes operational risks and allows missions to proceed with greater stealth and efficiency. It can fly farther into enemy territory, loiter over critical areas for extended periods, and quickly return without relying on external support. On the financial side, the X-1's efficiency is a huge cost saver. Fuel accounts for a significant portion of the operating budget for military fleets, and even small improvements can save millions over time. With the X-1, the savings aren't small, they're substantial. This makes the aircraft not only a technological marvel, but also a more economically viable option for long-term deployment. Environmental considerations also play a role. While military operations aren't typically associated with eco-friendliness, the reduced fuel burn of the X-1 aligns with global efforts to make all industries more sustainable. Even incremental reductions in emissions from cutting-edge programs like this can set a precedent for future aircraft design, influencing both military and civilian aviation. Speaking of the military, it's got that in the bag too. Amazing weapons system. The X-1's weapons system is where its advanced engineering truly shines. The integration of microwave technology gives it a strategic edge that few, if any, other aircraft possess. Unlike traditional armaments, microwave systems focus on disabling, not destroying. This capability allows the X-1 to neutralize threats in a precise and controlled manner. Microwave weaponry targets electronics specifically, which is a major advantage in today's tech-driven battle spaces. Imagine a scenario where the X-1 flies undetected into hostile airspace and disrupts all enemy radars and communication networks. Without firing a single missile, it can effectively paralyze enemy defenses, paving the way for follow-up operations. This level of control changes how missions are planned and executed. The inclusion of non-lethal options is another revolutionary step. In military conflicts, collateral damage is always a concern. By offering alternatives to destructive weaponry, the X-1 makes it possible to achieve mission objectives with minimal damage to infrastructure or risk to civilian populations. For instance, disabling an adversary's power grid or transport system without physical destruction can force strategic shifts without escalating to full-scale combat. The versatility of the X-1's weapons system also extends to adaptability. Its design allows for upgrades as new technologies emerge, ensuring it remains effective in rapidly changing combat scenarios. This adaptability is crucial in modern warfare, where technological advancements can quickly render older systems obsolete. So is this just great for the military and governmental uses? Not quite. Potential civilian uses. While the X-1 is primarily a military asset, its technologies have massive potential for civilian applications, some of which could revolutionize everyday life. The most immediate possibility lies in commercial aviation. Hypersonic flight could transform global travel, cutting transoceanic flight times from hours to minutes. This kind of speed wouldn't just make travel faster, it could also make it more accessible. High-speed transportation might become a standard rather than a luxury, enabling businesses to operate on a truly global scale and making far-flung destinations more reachable for everyone. The X-1's microwave technology, while primarily a military feature, could revolutionize telecommunications. Current wireless networks rely on infrastructure that is costly and vulnerable to disruption. Microwave-based systems could offer faster, more stable connections, improving internet speeds and coverage, especially in remote or underserved areas. Energy transmission is another area with huge potential. Microwave technology could enable wireless energy transfer, reducing reliance on physical infrastructure like power lines. This could be great for regions with difficult terrain or limited access to energy grids, as well as for disaster-stricken areas where infrastructure has been compromised. Even the precision control demonstrated by the X-1 systems could inspire innovations in fields like medicine. For example, its targeting systems could influence the development of robotic surgery, making procedures more accurate and less invasive. Similarly, remote-controlled technologies could be adapted for use in telemedicine, allowing specialists to treat patients in remote locations. These applications are speculative, but they highlight how advanced military technology often serves as a proving ground for innovations that eventually benefit the broader public. The revolutionary features of the X-1, its unmatched fuel efficiency, groundbreaking weapons system, and potential civilian applications, combine to create a platform that's far more than just an aircraft. Each feature, from its cost-saving efficiency to its non-lethal combat options, represents a step forward not just in aviation, but in how technology can shape our world. Whether it's cutting travel times, enabling more precise military operations, or influencing civilian industries, the X-1 sets a new standard for what's possible. Even then, this aircraft hasn't really had it easy by any means. Technical challenges. The X-1's hypersonic speed pushes the boundaries of what current materials and engineering practices can handle. At 4,600 miles per hour, the friction between the aircraft's surface and the atmosphere generates extreme heat, enough to reach temperatures exceeding 1,800 degrees Fahrenheit in certain areas of the craft. Standard aerospace materials would fail under such conditions, forcing SpaceX to innovate with advanced composites and thermal protection systems. These materials not only have to withstand heat, but must also maintain their structural integrity at extreme altitudes where air pressure is minimal. Heat management also extends to the internal systems. Components like avionics, communication arrays, and weapon systems must operate flawlessly in an environment where every part of the aircraft is subjected to intense thermal stress. SpaceX engineers had to design cutting-edge cooling systems to protect the X-1's internal workings, ensuring it remains combat-ready regardless of its operational speed. Another technical hurdle lies in engine design. Traditional jet engines can function only at subsonic or supersonic speeds, making them unsuitable for hypersonic flight. SpaceX adapted a small space shuttle-derived propulsion system initially developed for its hypersonic missile program to power the X-1. This engine doesn't just need to propel the aircraft, it has to operate efficiently at altitudes over 100,000 feet, where air is thin and fuel consumption becomes a critical concern. The task of balancing fuel efficiency, speed, and durability adds yet another layer of complexity. Integrating all these features, speed, stealth, and advanced weaponry, into a single aircraft without compromising performance has been another monumental challenge. SpaceX engineers had to ensure that the X-1's advanced camouflage technology didn't interfere with its heat resistance or aerodynamics, requiring innovative design solutions that pushed the limits of what modern aviation can achieve. But that doesn't mean it doesn't have any itself. Political limitations. Elon Musk's leadership style, often characterized by his determination to maintain control over SpaceX's projects, has created friction with the US government. While the Pentagon has shown keen interest in the X-1's capabilities, its officials have raised concerns about ceding too much authority to a private entity. For national security purposes, military leaders prefer a more direct line of control over strategic assets. But Musk has resisted, arguing that SpaceX must retain operational independence to innovate freely. This power struggle highlights a broader debate about the role of private companies in national defense. SpaceX's dominance in areas like satellite launches and space exploration has already disrupted traditional defense contractors. Now, with the X-1, Musk has introduced a military-grade system that rivals government projects in terms of both technology and cost-effectiveness. Such advancements raise questions about accountability and whether private firms should wield this level of influence over military assets. Additionally, Musk's international ventures, such as satellite internet systems for conflict zones, have fueled suspicions among policymakers. There's a fear that SpaceX's growing global presence might complicate US foreign relations. If the X-1 were to be deployed internationally, it could inadvertently trigger diplomatic incidents, especially if allied nations or rivals perceive its use as unilateral action by a private company rather than a coordinated military effort. Plus, things are a little complicated on the global level too. The X-1 aircraft could turn global military strategy upside down. Its ability to fly at hypersonic speeds, evade radar, and operate at altitudes beyond the reach of most air defenses gives it a strategic advantage unmatched by existing technologies. In theory, this makes the X-1 a strong deterrent. Adversaries might hesitate to provoke conflicts knowing that the US possesses such a highly capable asset. Beyond its defensive uses, the X-1 could play a critical role in neutralizing threats with precision strikes, potentially reducing the need for prolonged military engagements. However, this kind of superiority is a double-edged sword. The X-1's debut could spark an arms race among rival nations. Countries like China and Russia, which are already investing heavily in hypersonic technology, may accelerate their programs in response. This competition could lead to the development of countermeasures, such as advanced air defense systems or rival hypersonic platforms, escalating tensions instead of deterring them. On a broader scale, the introduction of the X-1 raises ethical and legal concerns about the deployment of hypersonic weapons. Unlike slower technologies, hypersonic aircraft and missiles leave little time for decision-making in crisis scenarios. This increases the risk of miscalculations that could escalate into full-blown conflicts. Additionally, international regulatory bodies have yet to establish clear guidelines for hypersonic systems, creating a legal grey area that could be exploited by various actors. The X-1's capabilities also challenge existing arms treaties. While it isn't technically classified as a missile, its ability to deliver precise strikes at unprecedented speeds blurs the line between offensive and defensive technologies. That's especially true when you compare it to other aircraft that already exist and have been in use for decades. Comparisons to existing aircraft performance metrics. The X-1 stands out as a true game-changer in aviation when stacked against some of the most advanced aircraft in the world, like the F-22 Raptor and the F-35 Lightning II. Both of these fighter jets represent the pinnacle of current-generation military aviation, excelling in speed, maneuverability, and stealth. However, the X-1 pushes past these benchmarks in almost every category. In terms of speed, the X-1 operates at an extraordinary 4,600 miles per hour, a figure that dwarfs the capabilities of the F-22 and F-35, which reach maximum speeds of around 1,500 miles per hour and 1,200 miles per hour, respectively. While these jets are designed for tactical combat and battlefield dominance, The X-1's hypersonic speeds allow it to outpace conventional air defenses and intercept threats at unprecedented rates. No fighter jet in operation today can approach the sheer velocity achieved by the X-1. Stealth is another area where the X-1 redefines the playing field. The F-22 and F-35 are known for their radar-evading designs, utilizing shape optimization and radar-absorbent materials to minimize detection. The X-1, however, takes this a step further with its advanced camouflage technology, which allows it to blend almost seamlessly with the sky. This feature has even managed to confuse high-level radar systems, a capability that places it in a league of its own. Altitude capability also sets the X-1 apart. It operates at an astounding 105,000 feet, far above the range of both the F-22 and F-35, which typically fly at operational ceilings under 65,000 feet. This extreme altitude provides the X-1 with a strategic advantage, as it can perform reconnaissance and precision strikes without coming into range of most existing air defenses. By comparison, the F-22 and F-35 operate at altitudes that leave them vulnerable to advanced anti-aircraft systems. Fuel efficiency, while not traditionally a top priority for military aircraft, is yet another area where the X-1 excels. Its 30% improvement in fuel efficiency compared to existing fighters not only reduces operational costs, but also extends mission durations and range. This efficiency, combined with its hypersonic speeds, allows the X-1 to accomplish missions with fewer refueling stops, increasing its tactical flexibility. But there's more to it. Technological leap. The X-1 represents a monumental leap forward in aviation technology, leaving even the most advanced aircraft of today feeling outdated. While the F-22 and F-35 are cutting-edge platforms, their designs are limited by the incremental nature of aviation innovation over the past few decades. The X-1's development, driven by SpaceX's expertise in hypersonic propulsion and aerospace materials, has shattered these limitations. Stealth capabilities are one of the clearest examples of this leap. The F-22 and F-35 rely heavily on reducing their radar cross-section, but they still have detectable signatures under specific conditions. The X-1's ability to actively camouflage itself, effectively disappearing into its surroundings, marks a paradigm shift in what stealth technology can achieve. This isn't just about avoiding detection. It's about rendering the aircraft virtually invisible, even to the most sophisticated tracking systems. In terms of speed, the X-1's hypersonic capabilities go far beyond traditional jet propulsion. Hypersonic technology allows the X-1 to respond to global threats in a matter of hours, making it a tool for rapid strategic deployment. This level of speed, combined with its altitude capabilities, allows the X-1 to operate in an entirely different airspace, one where conventional fighter jets simply can't compete. Altitude 2 is a domain where the X-1's superiority becomes clear. Operating at 105,000 feet gives it access to airspace that remains out of reach for most aircraft, including the F-22 and F-35. This altitude not only enhances its ability to evade defenses, but also opens up new possibilities for reconnaissance and strike missions. Traditional fighter jets, limited to lower altitudes, are far more vulnerable to interception and detection. The X-1's fuel efficiency, a feature rarely highlighted in discussions of military aircraft, is another key factor. By improving efficiency by 30%, the X-1 reduces logistical challenges, such as the need for refueling aircraft or forward operating bases. This gives it an operational edge, especially in scenarios where supply chains are stretched thin or missions require extended durations. The combination of these features, hypersonic speed, unparalleled stealth, extreme altitude, and superior efficiency, positions the X-1 as a quantum leap in aviation technology. It doesn't just outperform existing aircraft, it sets a new standard, redefining what's possible in both military and civilian aviation. Where the F-22 and F-35 are products of their time, the X-1 feels like a glimpse into the future, a technological benchmark that other nations will strive to match for years to come. We're not just talking about aircraft here. Elon Musk is changing the game with SpaceX to a level no one expected. Connection to SpaceX's rocket programs. SpaceX's rocket programs, particularly the Falcon 1 and Falcon 9, have set the stage for a groundbreaking leap into hypersonic aviation with the X-1 aircraft. The innovation and technological advancements that SpaceX has brought to the world of rocketry have had a direct impact on the X-1's development, particularly in propulsion systems, materials, and design efficiency. The Falcon 1, though a smaller and more experimental rocket, was a significant milestone as it became the first privately developed liquid-fueled rocket to reach orbit. This achievement marked SpaceX as a legitimate player in the aerospace industry. This innovation led to the development of the more advanced Falcon 9, which introduced the concept of reusability to space travel. By successfully landing and reusing rocket boosters, SpaceX reduced launch costs and made space access more sustainable. This focus on reusability, alongside their growing understanding of rocket engine design, provided a wealth of knowledge that was later applied to the X-1's development. The X-1 benefits from SpaceX's extensive experience in rocket propulsion. Unlike traditional aircraft, which rely on jet engines, the X-1 is powered by advanced rocket technology adapted to a hypersonic environment. This propulsion system, which draws inspiration from SpaceX's Falcon 9 engines, allows the aircraft to achieve unmatched speeds. The same precision in fuel management, thrust control, and efficiency that SpaceX developed for its rockets has been crucial for enabling the X-1's hypersonic capabilities. Additionally, the X-1's rocket-like engine systems offer more thrust per pound of fuel, allowing it to maintain higher speeds over long distances without the need for constant refueling. Another critical area where SpaceX's rocket programs have influenced the X-1 is materials science. The heat-resistant materials used to protect SpaceX rockets during re-entry are the same types of advanced alloys and composites used in the X-1. This technology enables the X-1 to withstand the extreme temperatures generated by traveling at Mach 5 and beyond. These materials are lightweight, yet incredibly durable, ensuring the aircraft remains structurally sound during high-speed flights. Without the knowledge and advancements SpaceX achieved in its space programs, these materials would likely not be available to the aviation industry for hypersonic travel. Thus, the development of the X-1 represents a natural progression from SpaceX's work in the space sector to the aviation industry. The company's work on reusable rockets, efficient propulsion systems, and cutting-edge materials has paved the way for the creation of an aircraft capable of flying at hypersonic speeds, making it a significant milestone in both aerospace and aviation technology, one that could change everything, paving the way for hypersonic travel. SpaceX's influence extends far beyond launching rockets into orbit. Through its innovations in rocketry, materials science, and aerodynamics, the company has played a key role in making hypersonic travel a reality. For years, scientists and engineers have been working on the concept of flying at speeds greater than Mach 5, but the challenges associated with heat, speed, and propulsion have been formidable. One of the most significant hurdles to achieving hypersonic flight is heat management. When an aircraft travels at hypersonic speeds, the air around it compresses and generates immense heat, which can damage or destroy traditional aircraft materials. SpaceX has developed advanced heat-resistant materials used in its rockets, which have now been adapted for use in the X-1. The same materials that protect rockets during atmospheric re-entry are being utilized in the X-1 to withstand the heat generated during high-speed flight. These materials ensure that the X-1 can maintain structural integrity even as it reaches temperatures in excess of 3,000 degrees Fahrenheit, far higher than what conventional commercial or military jets can handle. Additionally, SpaceX's advancements in aerodynamics have contributed significantly to the development of hypersonic aircraft. The X-1's design incorporates aerodynamic principles refined through years of designing spacecraft and rockets. SpaceX's understanding of how air behaves at high velocities and how to streamline an aircraft to minimize drag has made it possible for the X-1 to cut through the atmosphere at extreme speeds without losing control or stability. The efficiency in airflow, combined with a sleek design tailored to reduce friction, enables the X-1 to glide smoothly through the sky, much like how rockets are designed to slice through space. Furthermore, propulsion technology has been another area where SpaceX's expertise has had a profound impact. The engines in SpaceX's rockets, such as the Falcon 9's Merlin engines, are designed to produce incredible thrust while maximizing fuel efficiency. This technology has been adapted for the X-1's hypersonic engines, allowing the aircraft to reach speeds upwards of Mach 6 without needing constant refueling. The advanced rocket engine technology provides the power needed to push the X-1 through the upper atmosphere and into the hypersonic realm, a feat that no traditional jet engine could accomplish. In terms of broader implications, SpaceX's work on hypersonic travel could fundamentally change the way we think about long-distance travel, commercial aviation, and national security. Hypersonic travel has the potential to revolutionize air travel by drastically cutting flight times. Imagine flying from New York to Tokyo in less than 2 hours. This is a realistic possibility thanks to the advancements that SpaceX has made in aerodynamics, materials, and propulsion. The X-1's successful development could lead to the creation of a new generation of commercial aircraft capable of traveling at hypersonic speeds. Beyond commercial applications, hypersonic flight has enormous strategic implications for national security. Hypersonic aircraft could be used to quickly deploy military assets anywhere in the world, rendering traditional air defense systems nearly obsolete. SpaceX's advancements in rocket technology and hypersonic propulsion are positioning the company to be a key player in the defense sector, as well as opening up new possibilities for high-speed travel and communication systems. Ultimately, SpaceX's innovations in rocketry are not only shaping the future of space exploration, but are also breaking new ground in hypersonic aviation. The technologies SpaceX has developed in the aerospace field have the potential to usher in a new era of speed, efficiency, and global connectivity that will dramatically alter the way we travel and interact with the world. What do you think? Leave your thoughts in the comments below, and if you like this video, don't forget to subscribe to our channel. See you in the next one.